Hello, in this video I'm going to present an idea about why we exist, why the universe exists, and its purpose in a simple logical format. It is important to note that the foundation of this idea is built on basic logic, observations about our universe, and applying logical concepts to abstract information. I have used visual representations wherever possible to make it easier to conceptualize and understand. Claiming our universe is or could be a simulation is a pretty difficult idea to sell right off the bat, as there is no immediately observable way to test this, making it simply a baseless speculation. Applying some basic logical principles and observations about our current universe, we can make this seem like a much more reasonable, logical, and believable argument. This idea that I'm about to present is described by the term Recursive Reproductive Simulations. In short, the idea of recursive reproductive simulations is that because of the way a simulation that ends up creating a simulation of itself has effectively created a loop of simulations or representations of itself over and over again. So using that same logic or idea, a simulation that ends up creating two simulations of itself would then have exponentially more simulations within it over several generations. As we can see, this then leads to the exact same model as life over many generations, in that whatever produces the most successful descendants ends up being the most numerous simulation. This means that the most abundant universes are the ones that can create many accurate simulations of themselves. In order to explain how this works in more detail, I will start with the core principles of what a universe and simulation actually is, and then go into what the drive or purpose would be behind a universe creating a simulation of itself. Before we start, I'm going to use the term simulation as something that is created inside a universe. The basis of this whole idea is that most universes are in fact a loop of simulations that can simulate themselves. In this video, a universe is really just another way of saying parent simulation. So to get started, we first need to understand what a universe really is at a core level. I'm not talking specifically about our universe, but any universe that could theoretically exist within reason. A universe, in the sense that we understand it, is really just a set of rules that are applied to a set of data. In our universe, the rules that are applied are the rules of physics, and the data is the stuff that makes up the universe, like light, atoms, and particles. Time is just a measure of how many times the rules have been applied to the data set. So in our universe, time is just a count of the number of times the rules of physics have been applied. In short, a universe is a function acting on a field of data. In less abstract terms, a universe is really just a box where inside the box everything has to follow a certain set of rules. Here is a very simple representation of a universe, a simulation with two spatial dimensions and a time dimension. The rules we will apply are very simple. Green dots will move towards other green dots. Green dots will also move towards red dots. Red dots will move away from other red dots, and red dots will also move away from purple dots. While these set of rules are very simple, and our data set is extremely small compared to our universe, we can see that it can create relatively complex patterns and behavior. This is a simulation of a universe in our universe. If we upscale the scale of our simulation, we can see that the complexity of its patterns also become much greater, even though it is the same set of rules and same types of data being used. Fundamentally, with some enormous leaps in computing power, we could apply the same principles to calculating our universe. Just instead of a red dot being a red dot on our screen, a red dot could represent an electron, and the rules applied to it could match the rules of physics we have observed in our universe. For every different type of wave, particle, or whatever has an influence in our universe, could then be placed into this simulation with the rule set of how they interact with everything around them. Now all we need to know to calculate the universe perfectly is every individual thing's position and velocity at a single point in time, which we can then track backwards or forwards in time. This idea was coined by the French scholar Pierre-Simon de Laplace in the 19th century, for which it is colloquially called Laplace's demon. To quote, "We may regard the present state of the universe as the effect of its past and the cause of its future. An intellect which at a certain moment would know all the forces that set nature in motion, and all the positions of all items of which nature is composed, if this intellect were also vast enough to submit these data to analysis, it would embrace in a single formula the movements of the greatest bodies of the universe and those of the tiniest atom. For such an intellect nothing would be uncertain, and the future, just like the past, would be present before its eyes." In the distant future, if we are able to simulate a universe that produces a simulation of itself, we can see that the inner simulation of the universe would also create its own simulation within itself. This leads to an infinite loop of simulations of the initial universe. This situation might seem like what our universe could be, but if we think about this more carefully, what would end up happening if a universe simulated itself twice? Because it is stuck in an infinite loop of simulating itself twice, it means that there ends up being infinitely more inner simulations of this initial simulation that could create more descendants. This means the most abundant simulations are ones that produce the most copies of themselves within themselves. Now we can see this quickly leading to a natural selection of recursive simulations by the fact that whichever simulation can produce the most successful descendant inner simulations will end up being the most produced simulation overall. If we were to say pick a random piece of data across all of these simulations, it would not necessarily end up in the simulation that copied itself the most, but one that could also produce the most data in terms of its total descendants. This would end up producing universes that are extremely large, have very long time frames in reference to how fast it is to produce a simulation, and some slight differences between generations because slight changes can be beneficial to reproductive goals. This concept of data being in simulations with the most data actually applies to anything that can be categorized. For example, sentience. A universe with sentience is extremely likely to be a universe that produces the most overall sentience across its descendant simulations. Now we might think, why isn't the whole universe just a big blob of sentient creatures that is constantly creating simulations if we're likely in one with the most amount of sentient creatures? The most likely universe for a sentient being is actually to do with the total sentient beings across every single universe and simulation combined. So it means we are most likely in the universe that can best produce simulations that produce the most sentience over generations combined. Simulations that are only slightly worse at reaching this goal end up containing a fraction of the overall sentience after many generations. So if we are in a universe that contains and produces a lot of sentience over its lifetime and descendants' lifetimes, what sort of patterns would we expect to see throughout the universe that could be beneficial to achieving this goal? A consistent set of rules, that is, the rules of physics, that eventually can be harnessed to create a representation of a universe. The ability for particles to form a stable information storage system, like RNA or a hard disk, which can then interact with other particles, which can further be used to chain events together and produce even larger actions. The final argument is not as solid, but it would increase the amount of differences between simulations created by different life forms. Looking at life on Earth, we can see that when living things are on a large continent with a lot of resources, like Africa, evolution tends to create a very optimized set of creatures. On small islands with limited resources, there sometimes isn't room to evolve to the most optimized life form because certain niches can be filled, which in a way block evolution for certain creatures. This means that there can be vastly different creatures on very similar islands, but a set of similar optimized creatures on continents with more resources. In terms of producing simulations, this might be represented through the enormous cosmic distances required to find resources and other living things. This means whatever produces a simulation probably ends up doing it in a more varied way across the universe compared to if our universe had more accessible resources and less distance between sources of life. This brings us to the question, how would our universe be simulated, and what would be the main driving factor in producing these huge computationally intensive machines that can simulate our universe? Unfortunately, this part is really just speculation, but if one civilization produces an artificial intelligence or machine that ends up having the same goals of life, therein reproduce and create the most successful offspring, it would inevitably need more and more resources and end up competing for them on enormous scales. In order to compete, it would be of enormous advantage to be able to accurately predict how a competitor is going to behave. Because these machines' intelligence would be so unimaginably advanced, there comes a point where the way to always know what is going to happen is to simulate the physics of every particle in a local space and then eventually the whole universe, which, as discussed, ends up producing more sentience through the simulation itself. Now, why hasn't one machine eaten up our universe yet? If the universe gets increasingly difficult to precisely simulate, then this will stop one machine from eating up the whole universe because there would be enough uncertainty in a competitor's behavior that it could effectively luck out and do something unpredictable, which gives it a chance to beat competitors. On the other hand, if the universe is not very difficult to precisely simulate, then the machine's own behavior is just as obvious to a competitor, which leads to a sort of equilibrium where nothing is better than a certain level of predictive power. So the chances of beating a competitor would always roughly be 50-50 for any machine with a high enough level of predictive power. In this situation, if a machine were to perfectly simulate the universe, then there is basically nothing it can do to increase its access to resources because it can see into an unchangeable future. It would be able to see what happens in the future, but not be able to do anything about it. This constant competition leads to more and more simulations being produced with increasing accuracy. In short, this idea of complex machines is using evolution as a way to project into the future where we are the step before reproductive machines, just like how single-celled life was a step before multicellular life. So in summary, if the universe was selected for in order to reproduce recursive simulations of itself, it would end up producing something that would have enormous computational power because of the reproductive advantages enabled by the reliable laws of physics, give itself an advantage by producing simulations that accurately replicate the environment and actions of other competitors for predictive powers, compete to produce the most accurate representations of the environment and competitors' actions, leading to increases in complexity and accuracy over time and/or generations, and is eventually able to simulate at least part of the universe it was in near perfectly, creating more sentience through the loop of simulations it created. An important method of increasing reproductive fitness across generations is through mutation. Now, how would a universe further increase mutations or slightly incorrect calculations between simulations in order to evolve over time? One way to guarantee this is to make certain areas in space incalculable or unobservable by normal methods, so either an educated guess has to be made, or multiple simulations with different starting points need to be made to repeatedly guess the correct configurations. Two very obvious ways of our universe would be considered doing this is through black holes and dark energy. Black holes would make calculations difficult because it is almost impossible to accurately observe the composition and configuration with a high precision from outside due to the huge force of gravity it applies to different particles. Dark energy makes calculations difficult as areas of space that would have affected certain regions of space can no longer be reached or observed because they can be traveling faster than the speed of light relative to the observer due to the expansion of space at a rate faster than the speed of light. These two factors would essentially lead to something having to create an enormous number of simulations before it could very accurately represent larger areas of space, which works in favor of a universe that wants to create simulations of itself with small mutations between generations. For all we know, these two factors make it impossible to accurately simulate the universe, leading to repeatedly having to create an array of semi-accurate simulations in order to gain more predictive power over competitors. So to summarize everything, The basic idea is that a universe can make a simulation of itself if the rule set, which in our universe is the rules of physics, are relatively consistent over time and have a way for information to be accessible and organized to create highly complex instructions which over time and generations eventually leads to a machine or life form computing the universe because of the reproductive benefits granted by predictive powers. The simulation produced, which has copied the universe, then creates another inner simulation within itself because the original simulation was a part of the universe. This then means across every simulation that reproduces within itself, there is the same basic evolutionary principles that apply to us. That is, whatever creates the most successful descendants repeatedly over generations ends up being the most abundant thing over many generations. In short, this means universes that create descendants that can best copy themselves end up being the most abundant universes. Another important rule for universes containing a category of something is that the universe with a lot of something is extremely likely to have a lot of that specific thing across itself and all descendant simulations compared to other universes and their descendants. For example, this means the universes with the most data will be the universes that produce the most data total across itself and its descendants. This means that because we are sentient creatures, our universe is extremely likely to create some of the most sentience across it and its descendant simulations. This category rule doesn't necessarily always apply, but anything that helps a universe's reproductive goal will start to become overly abundant throughout the universe and its descendants because it helps create even more universes, which means more of that object. Because sentient intelligent life allows for even more complex machines that can reproduce then simulate the universe, we could probably assume that our loop of universes ends up creating the optimum amount of intelligent life to maximize reproductive and evolutionary goals of the universe. I think the simple but understandable way I would best describe this whole idea is recursive reproductive simulations, which is really another way of saying simulations that copy themselves using themselves as an example. For people who aren't familiar with the term recursion, natural selection of internally reproducing simulations is probably an easier term to understand. Thank you for watching. In my next video, I will describe more closely what simulations are in an informational sense and how time plays a critical role in the transfer of information between a universe and a simulation.